Hello everyone. So today, welcome back for the sessions again on product lifecycle management. So in our regular class, we had conducted the classes related to module 2 in product design, related up till design for X, where we spoke about various criterias which clarifies the existing design is a methodology implemented for design for X if it satisfied all the 6 to 7 criterias what we discussed before. So now in this current presentation, we'll focus on the further syllabus which is related to module 2, such as design central development model, strategies for recovery at the end of life, recycling in a product, human factors associated in a product design, and also the modeling and the simulation part in a product, how it will be applicable. Right. So let's move. So this is the outline what I told you already related to we will be discussing. Okay. So coming to the first one, which is design central development model. So what do you mean by design central development model? So there was an evidence-centered design approach created in the year 2003 by Miss Levy in Sandberg and Allman. Okay, so it was adapted in order to provide an evidence for adaptive content with evidence-based diagnosis in ACED system. Okay, so this evidence-centered design helps to provide an coherent argument for the quality of an assessment. So this design will evaluate how good the design which has been related to an product is. It assesses the quality of the design as per the requirement of the part. For example, you can see it provides a framework for developing assessment, the task that elect evidences that bears directly on the claims that one wants to make about what a student knows and can do it. So you can relate this to any example related to, if you take an example of a student in a college, so based on the quality of the answers what they provide, so you can assess a particular student. So in order to assess a particular student, there should be some assessment done. So we do it with respect to the internals, with respect to the assignments what we give, and also with respect to the PBL. Similarly, there will be some design assessment methodology, a design model which will be cultivated in order to assess the quality of the design. So this evidence-centered design approach was generated in the year 2003. So it could be related to any educational institutes or any industries or organization where the assessment related to the design is needed, irrespective of the stream in which it has been taken care. So this is a basic structure for an assessment design. So mainly you can see it has like 4 to 5 components. So one is the competency part, the evidence, the task, the presentation, and finally the assembly. So how does all these tasks will operate? So this is just showing the central modes of an evidence for centered assessment design. So in order to assess the design given by a person, so you should be having various things. So competency, coming to the competency, how good the design provided by the design engineer people is competent enough with respect to the other companies who are doing the parts related to similar kind of thing, because the design should be competitive and it should be strong enough and it should be very well versed and capable enough when it is compared with that of the design of the other company people who are into the same manufacturing of the parts. So this will check how competency the design drafted in an organization is. And then it has to be correlated with the evidence. So nothing you can prove that this design is good and it is compatible, you cannot prove blindly. You should be having some evidence into it. So the model which has been designed has to be evident with respect to some standards. So it will be referred with respect to some standards, how comfortable the design is, how flexible the design is it economical, is it easily assemblable. So there are many criteria what we have discussed in the first module also, which helps in proving the evidence criteria of the design which has been drafted. And once this evidence say that it is computable enough based on the evidence, then certain task will be performed. So this will be an analytical task which will be performing, not on actual thing. So analytically the design which has been drafted will be checked. So this is nothing but the simulation part what we do. So the part what we need to do the design, so that will be first cross checked by an prototype. So for prototype or any simulation of that particular part, some software oriented tools will be used. So these software oriented tools will perform the functionality of the task to cross check how good the design is working. So finally, if it is working smoothly, the simulation ran on well and there was no modification in the design needed, finally it will be documented, it will be presented, and a layout of the entire design will be handed over for the people who manufacture the part. So that will be taken care by the presentation skills, which is associated with the help of an computer, and what all aids they are in need to draft the specification of the drawing, sketch and other aspects. So finally, once this is ready, so then the parts will be manufactured based on the design sheet which has been given, and each parts will be assigned with certain tolerance range so that it will be easy for the parts to get assembled. And the parts where it will be assembled, it not be located in the same place where you have the centers for design, simulation and manufacturing. It could be in some other places also. So wherever it is located, the parts design should be very compatible and comfortable and user friendly to do the assembling and to get the required product. So this is how a central model of an evidence will be created for assessing the quality of the design of a product which has to be manufactured. So after understanding this central development model, you should be able to raise some questions as well. Like it answers a series of questions related to assessment design. The design central development model we just discussed. So it is helpful in answering a series of questions related to the assessment design. So what are these questions? So what complex of knowledge, skills or other attributes should be assessed? So while assessing the design, you what are the things based on your assessing? That is the complexity of the knowledge the person is having based on the design, or it could be the skills or any other attributes. How well he is able to tackle the complexity of the design has to be assessed. Every time a design will not be a very simple sketch. It could be a complicated sketch as well, or a medium stretch, depending upon the depending upon the quality and the size of the product which is in need for manufacturing. If it is for the purpose of defense, the transportation areas and for industries, the huge parts or the products has to be manufactured. In that, the design concept will be an complicated one. So the person who is going to assess should be very skilled person related to the design area who will be able to tackle all these. And further, what behaviors or the performance should reveal those constructs? So the behaviors or the performance of the design, how will it be revealed with the constructs? So constructs is nothing but the good constructive part of the parts for getting the assembled. So when it has been assessed and thrown to the design engineer, it has to assess what are its performance or the behaviors of a person as an individual who is taking care of these design aspects. And also what task should elect those behaviors. So the behavior of the person will be graded depending upon certain task which will be assigned. So even what task should be assigned for the behavior of a design person also should be identified. Further, how are the tasks presented? So the task formulation of the task is different and presenting is different, and it has to be presented in a proper way so that it will be communicated to the people in a proper channel. So how much evidence must be collected? So in order to do the assessment of the design, one more question is, what is the quality and the quantity of the evidence that has to be collected to say whether the design which is assessed is acceptable or not? So all these has to be scaled, should be drafted, designed by the team leader of the design team, and based on it, it will be assessed. So this is about the assessment part, how it will be done. So further, the evidence model will mainly consist of two parts. So one is the evidence rule and the other one is the statistical model. So these are the models which are being used for assessing the design as well. So hence we have to take care of the two classifications which are associated into evidence model. So evidence rules sometimes are also called the scoring model, and the statistical models are also called as the measurement model. So based on the type of the task assigned, the work product might be, for example, the selection of an answer option, a short answer, a piece of artwork for an assessment, and so on. So whether you're going with the scoring model or the statistical model, it depends upon which type of task you're going to select. So task could be anything, like selection of an answer which could be the best, or selection of an artwork piece which could be the best, or selection of a material for the part which could be best for manufacturing, or to design the selection of the design concept. A design engineer will throw n number of design concepts for a particular product, but as an director he should be able to select the design which is more compatible enough. So even that is a task. So it depends upon the task which type of models will be used, either it is of scoring model or the statistical model for the assessment. So this was about the design assessment model, and further you have to now understand the strategies which are involved during recovery of an product. You know, the product when it is launched, it will be having its own life cycle with all five phases. So when it comes towards the end of the product, every product will be having a life cycle with a decline stage. So when it comes towards the decline stage, then the manufacturer has to think about the recovery of a product at the end of the life. So what are the strategies which are involved during the recovery of a product at its end of the life has to be taken care. So this diagram is describing the decision making concepts for end of the life in a particular product recovery, right? So based on the product condition and the return volume, you can select the best product recovery option, right? So now the product condition and the return volume. So what is the condition of the product when it is at the decline stage? What are the returns and the sales it are getting, and is it very comfortable enough for the customers? Are the product is having many customers or less customers, whether the sales and returns are more or less? Everything you have to check for identifying the condition of the product. Similarly, the return volume, what is the quantity of the returns you are getting for the particular product which is in the market? So this will be decided based on the cost of the product, the price of the product, what is the actual cost of the product, and finally what is the market demand for the particular product. So based on the cost, actual cost, based on the price of the product and the market demand, you can claim the profitability for that particular product. Similarly, when it comes to the product condition, again, a product will be manufactured by consumption of certain materials. So these are nothing but the resource consumption. So resource consumption could be based on the material, or it could be based on the resource person which is needed for the guidelines, or based on the technicians which are in needed if it is an interdisciplinary project. So they have to outsource the resource people with respect to different streams if they don't have that people in the organization. Okay, so then they have to outsource the people to manufacture the product, or you may need to purchase the materials as a resource which is need to manufacture the part. So all this will be taken care in the resource consumption. And the materials and the resource what you are using, whether it is affecting the environmental impact or not, will be taken care. If the product is very good, it has good profitability, but the material which is being used for the product is not eco-friendly and it is toxic to the human being and the animals and to the environment, where we cannot go with respect to the go green policy, then also it is difficult in order to extend the product at its end of life. So the product condition will be tested in two different ways based on the material in which it has been manufactured. Is it eco-friendly or not? Sorry. And also based on the profitability of the product. By chance, if the profitability of the product is too good and the material which is being used, and when while operating the product also it is environmentally eco-friendly, then it is the best product to be selected for recovery option. So based on all these strategies, a product will be decided whether it has to be recovered or not. If it turns to be an less profitable and not eco-friendly product, then it will not be decided as an best product for recovery option. So these strategies have to be kept in mind while deciding whether the product has to be recovered at the end of life or not. So we have explained the strategies of the recovery in the last slide. So next comes for decision making. So how do you take the decision related to the best recovery options? So recovery options namely consist of reuse of the product or remanufacturing, yeah, recycle or disposing the product. So if it is more profitable and it has eco-friendly, then it is always preferable to reuse the product by making some modifications such that it will be in the market still for a longer run. And the second option is remanufacturing. How do you remanufacture when the product is particularly when the product has achieved his sales and profit to a larger extent in the maturity stage, and then it declines at the decline stage. At that time, it is an time for the manufacturer in order to redesign the product as per the requirement of the consumers and remanufacture such that the before the product get declined in the decline stage, a new product will be emerged in the growth stage of the product, and the product which is in the growth stage will be compatible with the product which is in the decline stage, even though at that time the product in the decline stage will get less amount of profit, still the company won't be facing any losses because they have already remanufactured a similar product with better modifications in the growth stage. So this is the second option for remanufacture. Similarly, they can go for recycling. So if the product was too good enough and it has achieved its total profit and you're sure that it won't be reusable again, no need of doing the remanufacturing part. So then you can recycle that product to get the material back so that you can resynthesis later. So this is the third option. And the fourth one is just disposing the product, saying that it is in scrap, it cannot be reused or it cannot be remanufactured or it cannot be recycled. So this happens when the material is toxic and it is not eco-friendly, or else the profitability might not be more, and or else the customers might be needing more other changes in the product. So based on these options, the people will decide whether it has to be recovered or not. So these are the different recovery option one has to take care when the product comes at the end of the life. So this is related to recyclability and end of life of a particular product. Explained already. So you can see this diagrammatically here. So the product condition. So how whether the part which has been manufactured is easily wearable, or is there any change in the dimension of the part which has been manufactured? What about the cleanliness and the maintenance level of the component or the part which has been manufactured? So all these also will be considered in the condition how the product is, along with the other part what I told you while explaining the diagram. Okay, so this is about the condition. So next you have to know, like, what do you mean by recycling of an product? So to recycle, you have to treat or process used materials or waste so we can use these materials again. So every material which has been used in order to manufacture a part or a product cannot be recycled. It depends whether the material used are eco-friendly or not, whether it could be recycled or not. If it is recycled, what are the process to be followed in recycling? So this helps in stopping us from wasting the useful materials. So we use many useful materials in day-to-day activities which could be exhaustible and non-renewable resources. So it is very efficient in order to safeguard these materials as well. So this recycling concept will help in wasting the useful materials again and again. Rather, we can get back the materials which was used before by the concept of recycling. So other things which helps is it reduces the number of fresh raw materials which are in need of, and it also reduces the amount of energy we use in developing or synthesizing these materials again for the parts which has to be manufactured. And thirdly, it also helps in reducing the air pollution. This, in what way you have to think, is sometimes if you want to synthesize a material and that material is of not an eco-friendly one, so it is toxic in nature and it could be affected for the human health as well as to the external environment, or it could pollute the air very much in drastically. So if you are reusing this material continuously, then it helps in resynthesizing the harmful materials, so that it helps in reducing the air pollution. Sometimes the material what we are recycling could also reduce the water pollution, because you are not sending back this waste to the water sewage. Instead of that, you are recycling and reusing it without polluting either air or water. And also it helps in reducing the amount of greenhouse effects depending upon the chemical synthesis process which are you are using to synthesize those particular materials for parts to be manufactured. So on the whole, this recycling concept helps in order to construct an eco-friendly environment without providing any harm to the living beings, either animals, plants, or human beings, whatever. And as the concept of recycling is very essential in any product. So examples of recycling are like reusing the plastic bags when you go to the supermarket. You know that plastic does not have any end at all. If or making the plastics to be dead is really difficult. It takes millions of years for them to get died enough, and hence the only possible way is to reuse the plastic bags. And also recycling paper, so it can be processed and used again. You know, for manufacturing the papers, we are cutting down so many trees throughout the world every year. So if you recycle the used papers, your paper bags, your whatever, then we can reduce the quantity of the trees which are being cut down due to the purpose of manufacturing papers, books, and other stationery items. And next example is melting food cans made from steel and making them into new food cans. So food cans usually stay for a longer period of time, and sometimes when it becomes waste because of any damage to the food can, then instead of throwing it as an waste or in scrap or disposing it somewhere, so it is better to recycle and reuse that steel by making a new steel can which could be continued again for a longer period of time. And also throwing the food uneaten outside, again it results in getting more amount of insects, pollution, and other diseases to the human beings. And but if you can use this uneaten food, you can compost it, while which helps in utilizing it in a good way rather than throwing the food which is not eaten. So these are some of the examples for recycling concept that could be considered for a product or eatable or in paper or anything rather. So after knowing the concept of recycling, you should now understand what are the human factors which are involved in designing an product. So this plays a vital role when it comes to the point of ergonomics. So ergonomics, it helps in seeing that the products which are being manufactured are ergonomically designed. So if it is ergonomically designed, it provides more comfortable for the human beings, or and human beings is nothing but the customers, so that the design of a product which is being identified is more comfortable with the human being. Suppose if you design a table which is of very complex and it is not at all convenient for the people to sit in the to people to use the table for a longer run from morning to evening, then we say that it is not ergonomically designed. We can take an example of stairs. If the steps width and the length is not designed properly, and if you are using those stairs continuously in everyday stretch, then you can get a pain on knee. Then the doctor suggests that these stairs are not ergonomically designed and hence you're getting the pain. So wherever it could be any area of application, not only in mechanical, when the design plays a vital role, it should be ergonomically designed also, so that it will be and friendly way of the part or the product which has been manufactured towards the human being. So in that, matrix analysis comes, in which the human characteristics are involved, what are the functions of the products are associated, and how an human and product interface are also being taken care. Along with that, the human being also provides certain ideas or the ideality concepts when a product or when a new product have to be designed. So these are nothing but the new product ideas, new product functions which would be embedded to the existing one. What are the design improvements could be for the existing one. So all these thoughts will be put forward by the human beings only. And also in ergonomical way of thinking, also human beings only will be providing certain factors related to the product which will be designed. So in a design of a product, human being plays a vital role, not only in ergonomical way but also in the way of thought, innovation and ideas. Apart from that, human factors are also involved in product design, while identification of the need for a particular product. Right, so finally the product need will be identified, what is the design will be identified, whether it is feasible, economical, whether it could be manufactured, all will be checked based on the evaluation concepts. So how it will be evaluated? So first it will be evaluated by measurement of the product characteristics. Once the product has been manufactured, the measurement of the characteristics of the product will be checked by the technicians, basically human beings only. and you will be having other than human beings some objects which evaluates and measures the characteristics of the product also, depending upon which product you are using. Suppose you want to test the dielectric measurements, piezoelectric, then you will go ahead with the semiconductor device analyzer, and depending upon the type of the piezoelectric material you are using, it will provide the functional properties. So it helps in evaluating the functional properties of a particular product which has been manufactured. So this is one way the human beings will now check what are the capabilities of the product which has been manufactured by determining its measurements based on the required characteristics, and further the material, further the part itself will be subjected to some device instruments based on the requirement to get those properties evaluated. And so these evaluated properties will identify how good the product is, how good it could be useful for the customers. After this, further it will be given for the customer. So the entire report of the measurement of the product characteristics and the evaluation of the product as a device will be given to the customer. So customer will evaluate and give his or her feedback. He can also check the trial of the product and provide his insight also whether it is acceptable or not acceptable, or still any other changes have to be made. So in each and every stages of evaluation also human factors plays an vital role. So this is the human intervention to an product design, right from the beginning until the end. And also in design process, we have studied different design process which was evolved in ancient times, like around 4 ancient design models, and also the existing design process also we have studied. So in each and every stages of the design process also there are involvement of the human factors. We have dealt with the systematic design process. Again, I don't want to go ahead with, I'm just showing you the interrelation of human factors with respect to the design process. And also we were telling about the ergonomical factors, right? So the basic human characteristics variables which are in need in a product design are described you step by step for different things. Suppose if you have made a product and it should be visualized through some sensing and auditory sensing, and even in visualize visual sensing also different type of perceptions and visual loudness, everything are needed, so which will be identified by the human beings only. Along with that, the audio sensing also will be checked, the loudness, the fatigue effect, the sound clarity, the localization, all will be checked by the human beings only. And similarly, the attention related to the particular product, and to identify or to detect any errors in the product which is being manufactured also will be taken care by the human beings only. And again, the channel processing, the processing of the channels for promoting of a product or to improve the marketability or the sales or the idea concepts of the customers, the processing of the channel is also being done by the human intervention in product design only. And also the memory part related to the design concepts. Here again, a design engineer might have done some design in a initially, and after 2 to 3 years some modification will be done to it, so he will be able to improve in a quicker rate if his memory is working memory is too good enough. Right, because human characteristics are very important in designing a product design. Sometimes they say that even if the design is done, the manufacturing part could be taken by a robot without human intervention also. All those are possible, but still the basic requirement of the human intervention which is needed in each and every stage of a product can be achieved only by the human way of thinking. Each and every part of human behavior and thinking cannot be embedded into a robot. and hence you should be able to identify the human intervention and the characteristics which are in need, which plays a vital role in any product design to the upper extent. And human factors are also affected in performance measurements. So it could be any performance like the delay in time, the complexity in the part manufactured, or multiplicity of a product, or visualizing or psychological effect related to the parts. So any items which could be related to the performance measurements also could be done in a better way by the human factors. And this is similarly, human factors are also helpful in image and impression measurements also. I don't want to go in depth in this. So if you can see only, you are able to identify. So I'll just proceed further. These are again the performance measurements. So basically the performance measurements depends upon the task given for the particular product and evaluating its performance, how better. So in every performance measurement, the human factors are always associated. So this was about the human intervention in product design. And now we are coming to the last part of our module 2, which deals with the modeling and simulation in an product. So you have to now understand when a modeling and simulation comes into picture in a product. So first we will define the PLM, the stages, the product will be designed, right? After successful design, you will be checking the simulation part of it using any CAD tool or any simulation links. Alright, before doing the simulation, sometimes it might be needed to do the mathematical modeling of the part and then compare it with the simulation. So here you are validating the theoretical approach with that of the simulation. So this is the more competency and complex level of comparing the simulations with that of the modeling of an product. So let us go through related to what do you mean by simulation and modeling in any product. So simulation continues to be the primary method by which the engineers obtain information about analysis of complex systems such as production assembly line, flexible manufacturing system, reliability system. So where you have the complex stochastic system, so this simulation helps to check whether it is running properly rather than going for a longer mass scale productions. But in the other hand, the modeling techniques are the way of representing the systems. So modeling techniques represents the actual system which could be there in a space or an environment. So based on the modeling techniques, then a product could be designed. A product cannot be blindly designed only on the design sketch. It has to be modeled, it has to be simulated, it has to be rapid prototyped, and then only we'll go for large scale production. So this modeling technique will provide you an idea for how well the product could work. Since a model of a system is a representation of the system that contains those elements that affect the objective of our decision, it is important to identify the most important elements and categorize them. So what do you understand from this? In the modeling techniques is always associated with the elements. So in order to get the required system in a model, you should be able to identify which are the required elements basically and how you will categorize those elements which are in need of. For this, you should be having a strong understanding of the decision problem required in order to group together the entities of a decision model. So without making an mathematical equation and decision model, it is very difficult to get the modeling of an particular product in the form of an system. So it again basically depends upon the what are the inputs you are taking in order to get an mathematical equations. Is these inputs are controllable or uncontrollable? So all these aspects have to be taken care in case of modeling of a product. So this is a description related to what you mean by simulation of a product, why it is needed, and how do you relate with that of the modeling of an product or an part? So this is a basic diagram which describes the modeling elements in a decision maker's environment. We can see different steps. So you have step 1, step 2, step 3, step 5, 4, step 5 and step 6. So what is step 1? So before doing any modeling and the simulation or identifying the modeling elements, first you have to check the performance measure of an part. So based upon the performance measure data, then you will go for step 2, which will predict or estimate the inputs which are uncontrollable. Here we are not focusing on the controllable part. Only the uncontrollable inputs have to be predicted. Once it is predicted, it has to be estimated. Which are the uncontrollable input parameters you have in a particular part what you are going to manufacture, right? And then you'll come for step 3. So you will identify the problems parameters. So based on the uncontrollable inputs, because these inputs cannot be controlled and it has to be done in a systematic way such that problem also will not come into picture. For that, these uncontrollable inputs have to be measured and the parameters have to be checked. What is the level of the problem associated with these uncontrollable inputs? So this will be taken care in the step 3. So after step 3, we have to go for step 4, which is associated with controllable inputs. So these controllable inputs will be never associated with any errors or any difficulties, because the input parameters what we are using we can be easily controllable. So no measure or count of the controllable inputs is needed. So once you gather the controllable inputs and uncontrollable inputs and you have measured the problem level, it is the stage now where you do the interaction. So by the mathematical and simulation model, you do check the interactions and see the vice versa, whether the problem associated with the uncontrollable inputs is able to be solved, or is it needed to add some other controllable inputs into it so that the variables or the problem associated in the uncontrollable inputs could be overcome. So all this has to be taken care in the interaction session. So we will be basically changing the components of x, y or other components related to the mathematical modeling equations until and unless we see in the interaction the problem associated with uncontrollable inputs are overcome. So once this interaction session is done, finally we take an action. Whether the modeling elements selected in doing the modeling of a particular system in virtual way, how it looks in comparison to that of the actual. So based on the interactions, the action will be taken whether this particular mathematical model is acceptable or not. So in this way, all the steps have to be followed associated to modeling elements, and then a decision have to be taken. So we will take a decision call based on all the 6 steps. So decision call could be yes, or it could be no, or it could be modify also. If it is a modify case, then again you have to predict the uncontrollable inputs. You should identify the other ways to overcome the problems associated with the uncontrollable inputs. If the problems associated cannot be removed, then it is better, cannot be solved, then it is better to change the uncontrollable inputs and see an optimized way to get a good mathematical model. So next you have to learn about the simulation of an product. So almost every evaluation in a stochastic system performance can be formulated by estimation of an expected value. So modeling provides an resemblance system to that of the existing product, and the simulation of an product helps in estimating the expected value for that particular product with respect to which type of application it has been used. So usually we use an continuous parameter for evaluating the expected values, and here V is always an open interval what we use and not an closed interval. Okay, so here J of nu will be equal to E suffix Y, or it could be mu into times of Z times of Y will be the variable. So you have to see now what is Y. So Y will be an random vector with known probability density function. So the function could be either V or Y. So Y is a random variable, and this random variable mainly depends upon the value of V, and Z will provide the performance measurement of that particular system. For example, in a reliability system, if J of V might be the mean time to failure, then Z will provide the lifetime of a system. So Z is nothing but it provides a performance measurement of the product. Here it is showing the lifetime of that particular product. And what will be the Y here? Y is the lifetime of the component, and V might be the component's mean lifetime. So these are the variable values which will be varying with respect to the performance measurement value of Z. So in any system analysis, we usually resort to simulation when Z is either known or is too complicated to calculate analytically. If it is able to calculate analytically, then no need of doing for simulation part. Analytically can be done by the individual, by his own, by the method or the approach what we follow. But when it is too complicated to determine the performance measurement of a product, then we rely on the simulation part. And hence the simulation is needed to estimate the J of V for most stochastic systems. So these stochastic systems comes when we do the mathematical modeling, which provides a closed approach to that of the system which we need to manufacture. Okay, so the principal strength of simulation is its flexibility as a system analysis tool for high complex systems. So one thing you have to keep in mind, simulations are used for high complex system where the mathematical approach by analytical tools are not possible. There are many simulation links and tools available. Usually the Monte Carlo simulation is a very famous and the common one which has been used to estimate the value of J of V for given value of V is equal to V naught. So we have an equation also for Monte Carlo equation what we follow usually as it has been shown over here. And I will be equal to 1, 2, 3 until n, and these are independent values and identically distributed random vector realizations for the parameter y, because y is associated with the random vector, and f will provide you the function of y with respect to the variables what you are getting. So this will help you in identifying the number of independent replications associated in the stochastic system. So this is a common way why the simulation is needed. What do you mean by a scholastic system, and which are the means which are being used to evaluate the performance measurement values, basically which are represented by the letter Z. So we dealt about the simulation of the product separately, modeling of the product separately, and together simulation and modeling is very essential in any part of the product to be manufactured. So these comes along with various parameters which has to be taken care. So these are nothing but the performance measure, uncontrollable inputs, parameters of the business, controllable inputs, interactions involving these components, action, scope and limitation, reverse engineering, feasibility problem, and goal seeking indicators. So all these we have dealt related to the modeling parameters already. So performance measure, controllable inputs, interaction with these controllable and uncontrollable, the action, and finally, yeah, action. Until here we have dealt already. So when we add on along with simulation, some extra parameters comes on. So let us see. So performance measurement, it provides you the value for the variable Z, so which provides what is the measurement of its performance for the particular product which has to be manufactured. So in any product what you manufacture, you'll be having the controllable inputs as well as uncontrollable inputs. So this helps in identifying what are the uncontrollable inputs and how to overcome the problems associated with the uncontrollable inputs, and then the parameters associated with the business. So these, how to deal with the parameters associated with the business. So these parameters are the constant elements that do not change during the time of the decision review. So there will be many parameters which will be keeping on changing while taking a decision for a particular product. But there will be some stagnant parameters which cannot be changed at all. So these are called as the constant elements which are very essential for the business. So these are called as constant parameters for any particular business. So even these things have to be considered while modeling the elements. And controllable inputs we have dealt about. Usually we won't get any problems associated with controllable inputs because it could be easily controllable, or it could be replaced, or it could be omitted also if it is not in need. And finally, the interaction involving the controllable and uncontrollable inputs. Are you able to tackle and solve it? If not, how you are able to overcome? Everything will be dealt in the interaction, where in the interaction even tells whether the controllable inputs, uncontrollable inputs which are used are required, or it could be overcome, yeah, removed, yeah, whatever. So based on the interaction session, the action will be taken whether the modeling and the simulation what we have designed is acceptable and approval for the manufacturing of the part or the product as per requirement. So once it is done with the action plan, then the scope and the limitations for a particular product will be identified. What is the scope for the product? How much amount of returns we get? What could be the sales? How huge market we can capture? Everything will be identified, and also the boundaries for that particular product will be identified initially before manufacturing itself. What will be the limitations of the product? Okay, now even all those things will be set directly along with the scope statements. Then the reverse engineering. So reverse engineering is a process of discovering the technological principles of a device through analysis of its structure, function, and operation. So is reverse engineering is feasible for this particular product what we have designed or not? That also will be checked. All product could not be done with the reverse engineering. So only few products will be able to go ahead with the reverse engineering also when it is needed for some modifications in the design. And finally, feasibility problem and goal seeking indicators. So what are the problems which are feasible and how the goals could be established based on these feasibility problems also will be decided. So these are all the parameters which will be associated while identifying the modeling elements. So this session gave you an outer review related to many things, simulation and modeling, recycling, the importance of human factors in product design, and also the design models which are in need. So thank you very much for listening. Please go through it, and further you'll be getting the assignments on which you have to answer and submit. Okay, take care. Bye bye.